mapping diagram reports and also in the harmonized UML report. We wanted to use those concepts even if they were not part of the new ISO standard. So we decided to put them into the Building Smart BSDD. The BSDD stands for Building Smart Data Dictionary. And that's an online dictionary holding definitions, official definitions for the properties and the concepts to be reused by the software editors. Because the same way you have a digital way to reference a concept when it's in an ISO standard, there is an express language used, you can reference the concept and everyone is on the same page. But when the concept is not in a standard, you still need a digital way to address it and to reference it. That's the goal for a Building Smart Data Dictionary. It complies to ISO 12006 and 33386. Those two standards make sure that it's a standard for the quality of the data entered in the online dictionaries. And this way, all the different icons in the center are able to access the news concepts, either if they are official concepts in the ISO IFC standard or in the data dictionary. And with that, I'll pass the mic to Edouard.
Yes, thank you, Sylvain. So in the next few minutes, I will present to you the French rail contribution sector to the IFC rail implementation and open beam development. Indeed, all the French sector partners have strong, sorry, I think, okay, it's, all the French sector have strong expectation of cost optimization in design, construction, operation and maintenance phases for complex and multi-domain projects. The challenge was to bring together, I don't know, no, I don't have any pointer, the technical experts and the domain business experts to use the IFC schema in real projects. To do this, the French sector was involved in all the organization of IFC rail projects, like he said already, from the PMO, Project Management Organization, which Guy was the PMO, and the other specific working group, with more than 20 experts, for which was involved in over 200 meetings. First of all, the implementation test was based on the use cases that were defined in the first phase of IFC rail project. And we set up 30 use cases, more or less. And this use cases was based on a real business process. Sorry. And then, secondly, we set up some unit tests. MIND and SNCF was participate to already all the unit tests from, for example, to the right, the positioning of cable ducts, the linear placement of signaling Eurobalises. But the key of the implementation test was the storyline. A storyline describes concrete railway projects in order to test all project test configuration with a realistic data set. It's the purpose of implementation test to validate the export and import of data for the realistic project And this is the fundamental purpose of the open beam. This storyline was chosen according to business cases that matter for SNCF or our mind. For example, we choose urban railway integration, or the deployment of modern signaling system like RTMS, or the upgrading of the track, which are based also on the substructure renewal. I briefly describe the three storylines. Donc, first of all, the ERTMS storyline. European Railway Traffic Management System is a multi-domain storyline because it addresses telecoms, signaling, track retirement domains. And the ERTMS is an interoperable system, not only at European level, but also at worldwide one. That's for why we have some colleagues from Italy or China who's involving in this storyline. Concretely, we tested 5 exchange scenarios and 8 unit tests from linear placement to railway spatial structure. And about software vendors, I would like to thank to AK Software and Rai Complete that allowed us to finalize all the tests the last year, at the end of 2021. Okay. The second storyline, which Vincent was the test leader, was the urban railway integration. The scope of this storyline was to manage the technical integration of urban railway system by analyzing IFC model assembly in a common open data environment. It was one of the most complete storyline because many domains was involved, like railway, energy, telecom, signaling, etc. And this storyline concretely tested 6 exchange scenarios, from a common spatial structure to spatial and mechanical interface, catenary, bridge structure, and etc. And the last one, storyline who is not already finished, is the platform renewal storyline. And this storyline will be finished at the beginning of this year. And we take advantage again from the contribution and coordination of French sector with a handover from SNCF to CETEC experts. I'll let the floor now to Vincent, who will present you the next step of IFC Rail implementation.
Thank you, Edward. So this afternoon we are here to explain you that we have contributed to provide a strategic standard for the BIM, open BIM process, that is the IFC 4.3. So we manage inside Man on with the stakeholders in Business Smart International this project. And we have delivered this, but we have to go on. We have to go on in the implementation process. Actually, it's an important milestone we have reached now. The IFC 4.3 standards and open data dictionaries for railways have been delivered. They significantly increase the capacity to use IFCs for the infrastructure on railways. We are now entering in the implementation process. This process should enable the railway owners to require the use of IFC 4.3 for delivery, and the railway industry to produce their data by using IFC 4.3 and open protocols. Sorry, just a minute. But implementation needs to maintain the effort between the railway stakeholders, the software vendors, the technical experts like Sylvain described just before, and Building Smart International. This team, this successful team that worked together in the phase 1 and phase 2 can enable implementation regarding the business needs. What are the business needs? The business needs are to manage implementation use cases per use cases, not completely implement IFC 4.3, but to implement it use cases per use cases through a sustainable process. What is the situation now? In infrastructure projects, exchange requirements for BIM processes are not commonly specified by use cases. Moreover, few railway use cases are correctly supported in IFC by existing tools. What the railway stakeholders want is to accelerate implementation by software vendors by specifying commonly the exchange requirements and the modeling requirements, use cases per use cases. And the number of use cases to be implemented is potentially unlimited. What MIND and SNCF have proposed to the IFC rail project stakeholders is to have a long-term strategy based on the relevant processes developed during the phase 2 of the IFC rail project. What we have proved during the phase 2 is that the software vendors get involved in the implementation of new use cases if and only if the representatives of end users, us, specify correctly and commonly their exchange requirements and modeling requirements, use cases per use cases, and if experts generate professional documentation on MVDs, use cases per use cases, and if the development can be supported by end users and IFC experts. By the end, the implementation of use cases should be validated by a qualification process to be developed complementary to the BSI certification program. What we have proposed to experiment in 2022 is an implementers platform. The implementers platform is actually a process where end users commonly push to the software vendors their implementation requirements, use cases per use cases, well documented, and where software vendors in this platform, where software vendors review them and have the opportunity to ask for details in order to decide to implement features in their software addressing each use case. This platform allows each software vendors to ask for end users or IFC expert support, and then to provide evidence of the implementation in order to qualify their tool regarding each use case. The implementers platform aims first to help end users to specify commonly their requirements for use case implementation, thanks to a documented methodology and standardized documentation templates. Secondly, it enables software vendors to make a decision about the implementation and accelerates the development of new relevant features in their tools based on IFC and open data dictionaries. The IFC Next Step project that is starting now aims to prototype the platform process in 2022. That means define the process, provide templates, test and validate the process, implement some use cases. And MIND and the SNCF have signed yesterday the protocol to take part in this project. So MIND and SNCF will be part of this project, and we are late. Thank you for your attention. And if you have some question, don't hesitate to push it in Brella.
Thank you, Vincent. Mercedes?
Yes, thank you very much.
I have a question. Probably people can see it in the chat. Do you think that network owners like SNF or SBB or the Deutsche Bahn, do you think that all the railway owners are going to, very interested in specify IFC 4.3 in their tender documents?
So maybe Edouard, as a network owner.
Yes, thank you, Masters, for your questions. Today some SNCF Réseau tender documents have already specified the use of IFC 2.3. However, to date, we do not have, we don't want to force suppliers to use IFC 4.3 since the validating is still in progress, but rather to use some openness and goodwill, I would say, to be able to progress on both sides in the implementation. But certainly within a few years, we'll integrate this IFC technical specification in our tender documents.
Is there any
Thank
question?
you. Yeah, I think that it...
Sorry, Mercedes.
Yes.
Is there any question in the room? One question.
Hello, I have a question about testing. So you were testing software, or are you testing that model final results? For example, you have some information and you're checking it will be okay, or what that was testing for unit test, I mean? Because usually in the test, like you have some code and you have you know what results will be. You just program that part, and after that you receive it's okay or not. So what is for?
The testing, well, thank you for the question. It's an interesting one. The testing was a multi-layer test, actually. You can also almost see on the left the V cycle from the business requirements, the exchange requirements, listing the different concepts, business concepts to be exchanged. We derive from several storylines, as explained, and then from those storylines, several unit tests, going deep, smaller and smaller bits of concepts to be exchanged. And once we have a small enough set of concepts to be tested, we created new 4.3 IFC files by hand, stating that this should be the result of this exchange for that specific set of concepts to be tested. And then we provided those new IFC files to the software vendors, requesting them either to import or to export the same result as this reference file. We used the term reference file. And once the tools were able to do exactly the same that we did manually, we tested the import, the small files import coming from the other software tools to close the loop, actually, to import and export the unit tests. And once those unit tests were working, we went up the V, gathering several unit tests and creating a storyline test, gathering several unit tests. And then we validated the output of this, thanks to the 3D viewers from the several vendors. So it was actually a several multi-layer test principle.
Okay, thank you. Is it good for you? Okay. I think as we are late, I propose you to continue with using IFC Today Prepares Us for the Future by Dina and Thomas. Are you online? Thank you, Sylvain, Vincent, Edouard. Have a nice day. So we switch to the next presentation. Dina, are you online?
Yes, hello.
Do you want to share your screen for the presentation, please? Ready?
I think I'm already sharing it.
Okay, so I just check with, is it good for you?
So in terms of the timing, would be great if we could, make it a bit more expeditive. So perhaps finishing 2:30 or before that, it would be great. Yep. Okay, cool.
So sorry for this delay and technical issue, but it should be solved soon. So maybe if you can have some word, Dina and Thomas, just to introduce your presentation before we start it. And sorry for the delay.
Yes, of course. I can start. I said something about myself earlier, but again, my name is Dina Egem, and I will present together with my colleague Thomas Angeltveit, and we will talk about how we have worked with OpenBIM and IFC in one of our rail projects, and how we think that has prepared us for the future. And yeah, we will talk a bit about the project and tell you about our digital journey and how we think OpenBIM creates value, and also wrap up with the lesson learned.
Okay.
As we started, can I ask for a question?
Yes.
When you talk about using IFC, and Vincent were talking actually about 4.3, which IFC have you used? 4.0, I imagine.
Yeah, and we have and we just standardize our own properties.
Okay.
So we just made our own standard since we're still waiting.
There wasn't anything.
Yeah.
Yeah.
Sorry, it takes time, but I don't know, Mercedes, if you have other question, maybe for the previous presentation, if the technical IT is not yet solved.
Yep, this is actually a question that I have it is quite general, so it is not also for the previous presentation, but also for this one, talking about the availability of resources, and by resources I mean people, train people that they know IFC, that they understand IFC. Do you think that this is a constraint in the industry at the moment?
Vincent, maybe for you.
Yes, thank you, Mercedes, for the question. Indeed, the training of people to use IFC in general on the new release of IFC, it's a real issue. And in the definition of the scope of the next step of the FCRA project, some people suggest that we work on the training documentation, but we decided to prioritize the documentation of the use cases description and to be more accurate about the process to define use cases and to document. To generate documentation for this, and then to work with software vendors to implement the standard. After that, it will be possible to provide some resources for training and to organize the training in the different countries. Maybe the important effort for training to have the return of investment for the industry will be in 2023 and 2024 when we will have some documentation to train people on use cases, and when we will have the tools to model infrastructure like we want to model them. Is it clear for you, Mercedes?
Yes, and thank you, Vincent. And for you, Dina, what was your take? Do you have any problem in non-consult? Well, for Dina and Thomas, do you have problem finding people that are actually not only 4.3, but also when you're thinking you're doing 4.0, do you have problems in terms of resource people, train people that they're knowledgeable of IFC?
We have worked with this now for so many years, and Dina is actually the first generation that's never worked with the traditional drawings, etc. So, and she's worked with now for 4 years. So So I think we have managed to kind of standardize in use of IFC and properties, and yeah, that's why we think we have a head start when the IFC standard will arrive, because we will just switch over and go.
Good.
Okay.
Good.
So, sorry I just want to switch the presentation. We'll do the extension of Lyon Metro Line B. During this time, the technical will try to find out a solution in order to have the screen from the previous presentation. So sorry, Dina and Thomas. We'll do the third one first, and you come afterwards. So I will call Eric, Rémi, and Pierre to present now the extension of Lyon Metro Line B to Hôpitaux Lyon Sud, BIM Spatial Coordination and Construction phase.
Thank you.
So it's a change.
Okay, thank you. Okay, it works. My name is Rémi Battisson, and I am the BIM manager of the Metro Line B extension project.
Tu peux le mettre plus près.
Ah, sorry. I'm the BIM manager of the Lyon Metro Line B extension project. I've been working on the project since the beginning of the construction phase in 2019. And I will share the presentation with Eric Gardon from Colasride and Pierre Derrieux from SPI. The project fits with Aegis digital priorities. For example, Aegis aims to carry out all its projects in BIM within the next 5 years. Aegis is involved in the development of a digital twin offer in order to build and operate intelligent and sustainable infrastructures. And also Aegis is acting for the implementation of IEC 4.3 and the development of the open BIM ecosystem. The project consists of the extension of the line B for 2.4 additional kilometers. The project begins in 2015, and the commissioning is expected in 2023. 2 new stations are created, Oulin Centre and Hôpitaux Lyon Sud. Hôpitaux Lyon Sud is the terminus of the line. It includes 900 places parking. 2 shafts are created also, a ventilation shaft between the 2 stations, and a launching shaft with ventilation and with an underground washing machine at Hôpitaux Lyon Sud. And the overall budget of the project is 391 million euros. Our client is Citral, which is the public transport authority of Lyon agglomeration. And Aegis is the team leader of a partnership composed by Aegis, Sistra, Atelier Schall, and AZC. The partnership is in charge of the project management and the contract management. And this includes site survey and technical synthesis. We decided to present this project because we based the BIM collaboration around an open BIM format, IFC and BCF. And this project is very interesting because it's a mix between punctual installation and linear infrastructures. As punctual infrastructures, I mean shaft and station, and linear infrastructures, I mean alignment and track. We produced the master design in BIM. In 2018, we proposed to Citral to implement the BIM during the construction phase, and Citral took up the change. The project has some advances in terms of BIM. For example, tunnel segments with the position of the drilling zone are modelized. We produce an as-built model during the construction phase. Train and pedestrian gauges are also modelized. And camera cones of visions and the visualization of camera views are also made in BIM. And Pierre will present this item later. And now I will let Eric to present the track work and linear system. Thank you.
Hello, everybody. I'm Eric Gardon, responsible of BIM within Colasrail. Colasrail is a world leader of railway infrastructure, able to offer turnkey railway systems that cover the world life cycle of infrastructure from design to construction and maintenance. Since 2014, Colasrail has designed a metro line system with BIM. This Metro of Lyon project is the fourth we have designed, and construct is still on the way. How does it work for this project? So we're starting with a BIM detailed design by using several input data as track layout. The project is from Aegis, and then we have cross sections and profile of the tunnel. This is their input. Then we do not post-modelize. We create directly the BIM detailed design with the model with GeoRail. GeoRail is a software using OpenBIM IFC4, but in this project we are in IFC 2x3. And it's in 2020 we have started the design. And this software has the capacity to deal with rail engineering directly. GeoRail replaced so totally the previous way of working. So then Colasrail proceeds to the complete modelization. We have in the scope of work one model for track work, other models for pedestrian walkways, cable trays, and fire ducts, and all directly designed with the same OpenBIM software. Then track detail design means also gauges analysis for both rolling stocks and also for pedestrians. It means it allows us to check and to prove the right alignment of a track in tunnel. These gauges are created with rules and then generated in 3D with GeoRail again. At design level, BIM track work experts analyzes the 3D volumes of gauges for rolling stocks and pedestrians. This is a view of a combination of different models. And then each data for objects are coordinated with requirements from maintenance and from site works managed by Aegis. And then Colasrail ensures the digital continuity from the design to the site work. We go ahead on BIM also for railways on this project, as we were in 2020. We have enriched BIM objects with data needed for linear projects, as IFC Rail is not published yet. So here we can see the BIM alignment, chain age, and some reserved space for track turnout and the object of turnout also. And then finally, after this model, from this model, the drawings are created directly from the model in GeoRail for the site work that started in December last year. Thank you.
I will present the technical synthesis. Technical synthesis depends on both project management and BIM management. It is complex because we have a lot of players. We have the technical synthesis team with a manager for each station or each shaft. We have the contractors for civil works, power supply, low voltage, plumbing, etc. And we have a contract manager for each contract. For a station or a shaft, to manage the technical synthesis, we have together the technical synthesis manager, the contractors, and the contract manager. We have technical issues between contractors' model. We have Each contractor has his own contract, and we have also a requirement interface between each contract. So we have to manage all these requirements during the technical synthesis. We have a common environment compliant with ISO 19650 that allows the collaboration between all the players. We use the collaboration platform BeamSync, which works with IFC model, which is an open beam format. So everyone can access to the model using IFC, and we don't have editor issue or software incompatibility. We make a clash detection on IFC model with the tool Solibri model checker, and we use BeamSync as a BCF server, so it is possible to exchange issues between Solibri and BeamSync automatically. These schemes explain the technical synthesis workflow. All the contractors upload their model on the platform. Once the models are shared, everyone can create an issue. For issues created by contractors, a validation is required from a contract manager. Simple issues are managed directly on the platform. And for the complex issues, the synthesis team organizes a meeting with all the players. And for simple issues, as for complex issues, the solution is recorded on the platform as a BCF. Using Beam is very beneficial because there is no waste of time for the reports and minute of meeting. It reduces the loss of time and money during the works phase. It requires full time for 2 people during 1 year to manage the technical synthesis. And we recommend to maintain less than 200 issues for a station or a shaft open at the same time. With more issues, the management of the issues is very difficult. And we can also notice that the implementation of a collaboration platform, there is no waste of time with emails, and there is no loss of information during the exchange. And now I will let Pierre present the next step.
Hi, I'm Pierre Derieux from Specity Networks and Railway Transport Companies. I'll talk you about virtual shooting as a use case of BEAM model. The virtual shooting is a way to validate cameras' position in the station. The objective is to ensure the full video coverage in public area and more particularly the passenger interchange area as platform, toll lines or escalators. The different constraints are to take account of mask, train position, or existence of an anchorage point. Before BEAM models, we need to deploy a work platform or a pole, as you see on the right of the screen. To pre-positioning the camera and take a shot. The constraints are to weight the building of the station, the accessibility of areas, the use of special materials, and the necessity of people's mobilizations, enterprise and operators, to validate the shot. This process is interactive and costly. In the same way, the test in real conditions that is with the train become very late and increase the risk of repositioning the support of the camera. Now, with the BEAM model, we proceed to implement camera on a floor plan in our 3D model in Autodesk Revit. We define the target of each camera and we adjust our viewing cone. Using our various configuration tools, we adjust the virtual shot under Navisworks software. As example, we can adjust installation height of the lens and focal length. Final setting allowed to optimize the control of passenger interchange area. The framing is validated by the operator directly on the BIM model. And in conclusion, the benefits are anticipation of building constraint, easily discussion with the operators before starting works, adjusting definition of support. We have a similar approach with other equipment, as for example, fire detector, for respect the installation's constraints and their maintenance condition as the accessibility to the equipment. We have created a constraint cone in the 3D model where any object can be fixed. This way, allow us to detect clash with other trade. As an opportunity with the BIM approach, we have studied the possibility to use an augmented reality headset to control all works during the building phase. The information about subject or clash on construction sites can be directly imported into the BIM Things model via BFC3. Thank you for your attention.
Thank you very much. Just to inform you, we'll switch the screen to the streaming mode, so like that we can have the last two presentations in visual here in this room. During this time, if there is some question in the room, maybe for this concrete example on a specific project, yeah.
Thank you. Florent Robert, Tunnel Study for French Tunnel Study Center. Yes. Oh, it's okay like that. How did you deal with the surrounding ground around the tunnel, and did you?
Hello? Hear me again?
We made a geotechnical study before the construction phase, but it wasn't in a BIM model. It was a classical study with the geotechnical skills.
Mercedes, do you have other question on the chat?
Yes, one relatively, hopefully quite quick question. You were mentioning about benefits, and one of the benefits was improved collaboration and early clash detection. Do you think the team has been able to quantify that in monetary terms, just to have an estimation of what that represents in terms of money saved really in rework? I know that it's very difficult, so yeah. The question is, have they attempted to do it or not?
Thank you for your question, but it's very difficult to give an answer to this question because I think each project has its own issues, and it's difficult to compare this project with a similar project.
To quantify.
But we can assure that there is no waste of time for the.
Good.
We don't have to prepare synthesis plans.
Okay, I think that now we are going back to the second presentation about IFC. Using IFC today prepares for the future.
We don't have waste of time for the preparation of this kind of plan, and we have no waste of time for the minute of meeting, and there is, I think it's very beneficial.
Thank you, Remy. Other question in the room? Sorry for the delay. We just need to make sure that it works for the next two presentations online. Maybe Mercedes, I'm sure you have other questions.
Yeah, but I think that in view of the time, if we are able to start with the presentation, maybe I have more general questions that they will be, they will be suitable also for the next presentations. They're more general in nature. are we ready to go with the second presentation offer using IFC today prepares for the future?
I think it should be soon ready. So it's for that, if you have another question, it will be very nice, so like that they have time to be ready.
Okay. Yes. Do you think that the information that you got that you developed in this project will be able to use easily by the operator, so by the people that are actually going to be doing the maintenance of the metro line?
We were sharing the information with the operator teams, Keolis, because we proposed to Keolis to join the BIM platform to access to the information in order to prepare the operation and maintenance of the infrastructure. So I think it will be beneficial for the operation and maintenance of the line also.
Okay, so you have been sort of having interacted regularly, catch-ups with the operator just to check that the information that you're delivering is the one that they need really to do the operation.
I think we should be able to switch to Dina, hopefully.
Great.
And Thomas.
Can you hear me now?
The operator and maintenance to just join the meeting, the project during the construction phase, and we can add some more information now. But I think we work more with the return of experiences for the last project.
So sorry, but we should be able to have it soon. C'est bon? So thank you, maybe Rémi, Pierre, and Eric. We switch to the next presentation with Thomas and Dina.
Yes, great.
Thank you. It's every time very interesting to see the development of BIM into a real project. It's where we can make sure that end users can use all this development implementation we are doing so far. So thanks, Dina and Thomas, to present your using IFC today, prepare us to the future. So you can speak now. Thank you.
Yeah, great, thank you.
And sorry for the delay.
No problem. It's interesting to hear the other speakers as well. So as I said earlier, we will talk about how me and my colleague Thomas Ankeltveit, we talk about how we have worked with OpenBIM and IFC and how we think that has prepared us for the future. So here's our agenda. We will talk about our project, complex railway project in the heart of Drammen city in Norway, and our digital journey and how OpenBIM creates value and lessons learned from the project. Some facts about our company Norconsult. We are Norway's largest and one of the Nordic region's leading interdisciplinary consultancy firms. And we are 4,600 employees, where we are 1,000 people working within transport. And so here I will show you a background for our project. It's a project movie. It's Norconsult's largest project ever, and it involves full rebuild of Drammen station with new platforms and tracks. And the tracks are to be raised to resist a higher flood level. It also contains demolition and rebuild of the bridge over the tracks, as you can see here. We have a 700-meter cut and cover concrete tunnel, and this tunnel is built with an open construction pit, as you can see here. The concrete tunnel passes into a soil tunnel built in loose deposits. Then we have a 6-kilometer double-track rock tunnel connecting to the existing line or track back in Kobbervikdalen. We have groundworks, superstructure, and catenary system, electricity and telecom of all the section. And it's a demanding construction phases in a high populated area in Drammen city. And here are some facts and number. Our project's owner is Bane NOR, the Norwegian Rail Administration. We have several different contracts, both EPC contracts and design build contracts for both main works and pre-works and everything. And one of the main contracts, which we call UDK 03, is for the civil works, where we have 25 different disciplines, and we have reduced the number of drawing by 90%, and we also have more than 500 IFC files. So it's a huge contract. So now Thomas will tell you about the history.
I will try to describe how we identify the need of innovation and open BIM in this project. And in order to do that, we have to go back to 2014 when everything started. And Dina is still sharing screen. I think. Yep. Should share. If you can change back. So if you can change back, it would be great. Could you get Dina's screen showing? Thanks. So back in 2014, we started with just searching for different alternatives. And this is nothing new, but I'll just show it so you understand the process. We had the different alternatives with tunnels, bridges, etc. And it was all about finding the best ground conditions and the balance between the ground conditions and costs. And early in 2016, we had our recommended alternative. And I have a project video from 2016, and it's really fun to look back at just old videos. And this is actually the same video that Dina showed earlier, and I think it's kind of laggy when we show it now virtual, but we can see that the things has really happened with technology. And we then started with the detailing phase, and now I'm kind of getting to my point, because we tried to model and illustrate all the different phases. We saw that the buildability, if that's a word, that would be really challenging, and to build and maintain the train traffic at the same time, it's also a huge challenge. We had complex interfaces between contracts, and also this mix of design, build, and EPC contracts. So to kind of summarize the challenges, complex construction, several contracts, challenging interfaces, and after we worked with our site model, we saw that we had to have information on objects to have control. We couldn't just keep on doing or having the information on layers in a DVG. And the last challenge we saw was the information loss. When we were supposed to hand our work over to several contractors, we had been working with this project for 6 or almost 7 years. And the question was how we could transfer more of our knowledge to them. And our solution was, of course, Open BIM. We decided that we had to get rid of DVGs and use IFC. We made a plan, or a BEP, a BIM execution plan. And we saw that we had to work a lot with change. And I will try to explain a bit more how we work with change. And Dina will talk about our BEP later. To overcome challenges, we had to renew ourselves. We had to change our mindset and culture. We had several internal and external barriers, including skepticism around starting with something new. And of course, we had people that were asking why we should do anything new at all and not just wait for the industry standard to get ready. And of course, we had to work a lot with innovation. And if you look at innovation, we like to define it as initiatives that's new. It has to create some sort of value, and it has to be implemented. It's not an innovation if we can't implement or scale it. And when we talk about implementation, we have to think about how different we are as humans. We have the enthusiasts and visionaries on one side, and they hate structure and they love the untested. And on the other side, we have people that love stability. And this difference makes innovation difficult on a corporate level, because the scaling of the good initiatives, it kind of gets stuck in the gap. But if you look at digital innovation, we can close the gap with technology. We can create new processes and automate things in a whole new level. And now we are able to talk about scalability and even how we can push the industry further. And to get this acceptance to do something new in both our internal organization and from our client, we had to use the corporate strategies to convince and create trust. In our consult, we had the ambition to be in front and push the industry further. And in the infrastructure area, we had a goal to be able to deliver drawing-less or fully digital projects by the end of year 2020. The Norwegian Rail Administration, at their side, had a strategic goal to at least use BIM in all projects, and that was something we could use internal to convince our organization and say that our client haven't kind of ordered it, but the strategy says they want it. And when we then got the go internal, we can use that momentum we created to just get the acceptance from our client as well. So another thing we saw that if you want to do something new, it's much easier to do that if everyone is in the same boat. And that's really something we saw when we started our first pre-work contracts. Because when we then started with the contract named UDK 27, it was really not good. It was a lot of things that were missing. The contractor didn't get all the information they needed from the IFC files. Some files lacked some details. And it was even a huge challenge for the site manager to not have any drawings at all. But since we did this as a team, we just evaluated and delivered a better product to the next pre-work contract. And this was still not perfect, but we spent a lot of time to evaluate that process as well. So I know that if you haven't spent that much time on change and to do this as one single team, we had been discussing money and having this blame game instead. So this was a really, really important thing we did.
Thank you, Thomas. So now you have presented how we identified the need for change and how we utilize the pre-works to learn from them. And when we started to work with the BIM execution plan for the main contracts, we had to understand how we produced and delivered geometry and information in a standard project. So this is how we normally solve a standard project, where each discipline uses suitable software to produce drawings, and the information are to be found as text references on drawings. And we also produce models, which are showing the geometry, and perhaps you can find some information on the layers, as you can see on the right-hand side. but we had to handle all the information found on drawings in our models, both geometry and the text information. So in order to get all of this information, we had to standardize. So by using plugins and fixed setups, the programs talks the same language. And now OpenBIM are used as exchange format, which is used as a common source of information, and it also communicated to all parts of the projects, as you can see here. So now I will show you our actual workflow and how we work with this project. The IFC files are in the center of everything we do. First, each discipline uses a suitable engineering tool like Revit or Civil 3D for their models. By using a plugin, here is easily shown, we include information on the models, which among others is used for production of the bid documents or specifications. Further, we can see that the IFC files also are in use in a whole project view model, which ensures a common platform so that all project employees have the latest updates. And this model is, of course, also provided to the project owner, involving them in every process of the project. And our project owner are also involved in the multidisciplinary control, where the same model again is in use. Here, potential collisions and conflicts are detected, and we use BCF files as exchange format. So today we actually have uncovered around 10,000 issues in the program that we use that are shown on the video here, BIM Collab. Another important use of the model is illustration and project videos. We have already shown you our video of the project, but we also have used it for site-to-signal controls with train drivers to see if we're actually building something that we can use. And again, new ways of working in our organization requires changes in our clients' organizations. And we saw that when models was our only delivery, our client needed to change both mindset, but also routine, software, hardware, and everything. So now I have been thinking about this internal part, as you can see in the red circle. But we need to look up and see how it actually affects the bigger picture. We see that it requires changes from the outside of the project team or project owners. And when we change from drawing delivery to models, it requires changes in systems for receiving, reviewing, use, and archiving and everything. So we claim that OpenBIM creates value. As we've been talking about, information flow is important, and every affected part of a project requires some kind of information. And the information transfer and information flow is a demanding process. This is a typical picture of how information traditionally are passed between different sectors, where each discipline has their own structure and language. We have repetition of information, and we have loss and lack of information. There is no common structure here. Going from this to this, using OpenBIM, we can see that the picture is simplified. And to illustrate, we will take one example from one of the important sectors here. When we as engineers are working with the design phase of a project, meaning produce the actual work basis for the contractors, we do obtain a lot of important knowledge. So, as Thomas said earlier, how do we transfer this knowledge to those who will actually perform the construction work? Ideally, the information level and information transfer would be illustrated like this black curve here. But when we transfer information, we do have an information drop illustrated here in the red curve. One solution for closing this gap is using IFC and properties, where a lot of information are transferred and connected to the specific objects in the model. But OpenBIM has also given us the opportunity to rethink the way we are working with the bid documents, and this is an important part. Because bid documents are normally a manual job produced independent of models and drawings. As we see from this figure here, traditionally we are missing a common source to information. This causes mismatch between drawings and bid documents and resulting in a lot of potential conflicts in the construction industry. Using standardized allows the contractors to interact with the contract and see how different objects are highlighted. You can click on a specific object in the model and look at which properties and codes it has connection to. And you can also click on a code in the specifications to see the actual object in the model viewer, as you can see here in the movie. And here is a real example from one of our largest contracts, Udica 0. It has more than 500 IFC files connected to it, resulting in almost 7,000 contract posts and a PDF containing more than 5,000 pages. And we don't think that we would be able to create this without rethinking our work methods.
Dina, just a moment. We don't see anymore the screen here. Just few minutes, few seconds, sorry. Just to make sure it appears again. So just to tell you also, at 3:15 there is a coffee break normally, so we may extend our session for some minutes, if there is any question anyway. And you can visit also the exhibition center where there is all the companies presenting their activities. Soon we'll continue with the presentation of Tina. I hope so. Sorry, Tina, it's the second time we have a break with you.
No problem.
Technical issues will be solved soon. So we are experimenting this the first session. I don't know if there is a question to Tina so far in the room or Mercedes in the chat. Yeah, one question here. Thank you very much.
Thank you. Thank you very much. Dina, thank you very much for your presentation. And I have a question because you explain what your company do, but how I can use IFC for the future?
So Dina, are you online? Are you with us? Another problem maybe. On est toujours connecté. Adina, did you hear the question?
I just wonder if in the meantime I will be able to ask a question.
Dina, can
Yes.
you hear us?
Can you hear me now and see our screen?
Okay. Just go back to the question.
Yes. Dina, thank you very much for your presentation. Can you hear me?
Yep, I can, but we do have some few more slides.
It's fine. Because you present your company with a lot of what you do, but how I can use IFT for the future?
Thank you. Thank you. Did you hear the question?
Can you repeat it, please?
Okay. Sorry again. The last one.
Yes. How I can use IFC for the future, for me?
We have been working with it a lot in our company, and how we have done a lot of change for us people. But you need to have a whole project team with you on your side, we think, and also your client, so that you actually can learn from the same things. And we have to wait for the standard or do as we did, prepare to make our own standard for the properties and information. But Thomas will come back to that later, but we didn't find the perfect projects or waited for the perfect project to appear. We just had to, what can we say, jump in it and try for one project. Do you want to say something?
If you just jump to slide, the achievements slide, I could just take that now and you can round off if you don't have time for more. I don't know. Because this is, we think that everything we have done will give us a head start when the IFC standard is ready. We have established this culture of change and also a sharing culture, and we think that that's really important, and that's something that gets the organization ready for the future. And we're also seeing that innovation and collaboration is really close connected. We don't think we're able to do everything within our four walls. So we need new competence, and we need close collaboration with clients, developers, even startups to meet up what's coming. So we have a kind of our equation, and that's culture of change plus sharing culture plus innovation and collaboration. That's what makes us able to implement things and to scale them. And that this equation, we think that this is kind of the key for the implementation when the IFC standard is arriving. It's not only software things, it's a lot about how we are as humans as well. And another thing we have seen is the importance of having high digital ambitions in projects that last for many years. This graph is showing how we developed, how the development in the industry is going exponential. And if we have locked the digitalization level when we started the detailing phase back in 2017, 2018, we would have a huge gap when we're finished in 2025. So since we tried to do something new, we worked a lot with innovation the first years. And this is why our project is not outdated yet. We are kind of modern project. And we're also seeing that the gap in the digitalization level in 2025 should be much smaller. And we have a video to wrap up our presentation, and we just texted it in English. So hopefully it will run smooth.
Yes.
Thank you for listening.
Okay, the screen is back, so Dina and Thomas, you can go back to your presentation. Sorry for this delay, and thanks for the question. Dina, are you online?
Yes, but I've been sharing the presentation now.
We have presented, but
yeah.
Okay, you didn't hear anything?
Thanks. Yes, we can see that.
But Thomas did present this now 2 minutes ago.
Mm-hmm.
You didn't hear it?
No, we did hear it.
Okay, let's continue.
Good.
Yeah, just show the video, and I think we're done. I think we presented something you didn't hear now in the last minutes, or?
Yeah, I think the last slide was not presented yet. Yes.
Which slide didn't you hear? Because I think some of those are online did hear the whole presentation, or?
Yes, it's a bit difficult to know. Sorry that I interrupted. For those of us that are online, we actually saw already the achievements, actually as an answer to the question that was made in Lyon. So and then we talk. Thomas spoke about how they have bridged the gap between, also that they are actually building because of the users of IFC, they have been able to have a project that it is to the newest standard, even though they started in 2014 with the project. So that is basically they managed to keep current the project, even though the project has been has started. I don't know why I say 2014. I was in my mind that it was 2014.
Yeah, but it's
I think that
the actual project started in 2014, so it's not wrong.
Mercedes, do you know if Jorge is online?
Okay. Jorge is online. He should be. He told me that he will be online. He's following in streaming.
Okay,
So
if you can just make sure that he's doing his presentation is not yet online. Do you have a video, Dina and Thomas, to present? The last one, or it's what I thought I understood?
I mean, there has been shown already, talked about what were the benefits. And I'm going to come back to a question that it is exactly also similar to the one to the tunnel that I asked to the person, for the metro in Lyon. It's like, have you been able to quantify these benefits in terms of also monetary benefits when you compare? I know that it's very difficult, and probably the answer is going to be the same. It's very difficult to quantify because no one project is exactly the same, so you can't compare, right? But is there any moment in time that you have been able to quantify what is the monetary benefits of actually using IFC?
Yeah, we do, or we only started the construction with the main contracts now last year, so we haven't had the big numbers yet. But what we can say is that the project is still on budget, and we do see that number of change orders in the construction contract have a positive tendency. From the first pre-works that we saw until now, we do see a decline in numbers, so that's positive.
Yeah, exactly.
And another important thing is that, as we've been talking a lot about, is the change in culture and mindset for our co-workers. And we are pioneers in our company, and that has a high value.
That's good that you're saying that the change order. I think that's kind of, if you look at the history of normal projects of this size, and you think about how long or how many change orders and how long historical they take, and it's a good way.
So we're looking forward to see when the main contracts have become more realized and build more to see.
Good.
Jorge, are you online?
Yeah, I'm online.
Okay. Can you share your presentation, please, just to make sure it works? Because we had some difficulties, not from Dina, it's here. The problem is here, so we're trying to solve it every time.
I think I'm
sharing
my
Jorge, just a moment. Thanks Dina and Thomas for the presentation.
Thank you.
Thank you very much, Dina and Thomas. Now Jorge will present the digitizing to improve railway line management. Are you online?
Okay. Yeah, I'm online, and I think I'm ready to start. I'm not sure if you see my screen. Not yet?
Not yet. Okay.
I don't know what is happening because it seems to work properly. Now?
Yes, you can start.
Yes, now we can see it.
Okay. Thank you. Hello, everybody from Spain. I'm going to start this presentation about our project of digitalization of a new railway line in Spain. First of all, I would like to thank the organizers for make this Congress possible with all the difficulties that we are suffering worldwide. And let's start introducing, oops, I don't know what is happening now.
Okay, perfect.
Perfect. Sorry, I have some troubles with my computer. Okay, now I will introduce Regina Diaz, that is the technical director of Ferrocarriles de Gran Canaria and is the promoter of this project, and myself, Jorge Torrico, being the Puri director in INECO. I'm very involved in BIM adoption, especially in public sector, both nationally and European level. INECO is a public engineering company, over 3,000 employees that belong to the Spanish Ministry of Transport, and specifically the ADIF, that is the railway infrastructure owner, Renfe, that is the railway operator, and ENAIRE, that is air navigation operator in Spain. I'm going to present this new infrastructure in Spain. It's in the Canary Island, that is in this southwestern part of Europe, in this corner of Europe, and we are talking about 60 kilometers of railway line, a new railway line between the city of Las Palmas in the north part of the island, with a population of about almost 400,000 people and 700,000 people with the towns that are around the city, and connecting to the touristic area in the south and through the airport. This is the infrastructure, 60 kilometers of railway line, and with a focus on especially sustainability by minimizing the use of natural resources and promoting energy self-consumption, and innovation through with the contribution of a digital environment and creating a digital environment to manage all the works of the construction and further the maintenance and exploitation phase. So this specific project is about to digitize documentation, because all the detailed design projects are already done, were done almost 6-7 years before. This is a long-term project, and we have the chance in this moment to create this environment, digital environment, and to transfer everything, all the documents, to a digital environment, creating a BIM strategy that I'm going to explain, in order to have for the future the digital twin of the line in the exploitation phase. So the main figures of the line, it's about almost 60 kilometers, 50% of them are tunnels, maximum speed of 160 kilometers per hour, double track in almost all the section, 11 stations, workshops, depots, and all the facilities. And we are talking about a budget about 1,650 million euro. So this is the infrastructure development. The first I have to say is that we have and starting point that was those detailed design projects, because in Spain the most common kind of contracts are design, bid, and build, and in this case design was already done. So in this project we were not going to make engineering. Authoring is protected by law and contractual issues, so we were only in charge of transferring all the data, all the documents to a digital environment of about 7 sections of track, 11 stations, depot, maintenance, and electrification. So we have created a global BIM strategy for the entire infrastructure, creating a common documentation ecosystem based on ISO and the national standard 19650, using open formats for information capture, exchange, and management, a multi-vendor software approach. There were many software tools used to create those models, at least 7 or 8 different tools, and the use of CD platform, in this case, UseBeam platform, and with the idea to be active throughout the entire construction and of course, the exploitation phase. This is the schema of the documentation ecosystem. The main is a BIM manual describing all the BIM uses for the construction phase that are mainly not only to create as-built models, but programming and cost estimating and to follow the construction during the whole construction phase. Defining roles not only for the contractor companies and their supply chain, but for the project management office and the client as well, to define a collaboration strategy, quality assurance for the whole construction phase, model structure, and so on. And with the use that we thought that we need a classification system specific for railways, and we use this SCF class, that is a Spanish classification system focused on railways, but we have the lack with the development of IFC format, because the IFC 4.3 is not yet implemented in the software. So we had to use IFC 2.3 or 4, created for buildings, but use a complementary tool, this classification system, in order to have all the data well structured and identified, and providing as well documentation tender for the following phases. So we have made reverse engineering, non-designing, only transforming information from CAD to BIM, and sometimes using some native formats in the software, in the proper software, to create BIM models. And we realized that in a 60 kilometers infrastructure, we have to move forward from the BIM scale to a territory scale in a GIS tool. So we took all the detailed design, transforming to BIM, and integrated all of them in a huge BIM model, and transferred this huge BIM model to GIS tool, creating a common database for all the data of the infrastructure. So I'm not going to stop more in this detail, but only for taking into account the size of the project. We are talking about more than 200 BIM models, considering that one station is only four IFC models. So I'm sorry. We have more than 100 models from the infrastructure, the section, alignment, earthworks, track, drainage, railway systems, and geotechnics with the terrain models of the terrain with all the layers in order to take into account all the variables need for the construction, and depots, contact area line, windmill park, etc. We have some pictures from some of those models that were made with different kind of tools. And this is a small portion of the integrated BIM model, but we realized that it was very, very difficult to manage so huge BIM model. And why we decided to go through an open BIM approach, specifically for the multiplicity of agents. We are talking in this process of design, bid, and build, more than 20 contractors in the construction phase with all their supply chain. So we have many agents acting at the same time, and we were worried about temporary interoperability using proprietary formats in a process that is for 5, 6, 10 years. So it's not a very short-term activity, it's long-term. So we prefer to use IFC and keep this temporary interoperability in the whole process. We use IFC and this IFC 2.3 and 4 for all the models, and in all cases with only one exception, that is the structural reinforcement, that it's going to be implemented only in the construction phase. And using as a support this classification system that allows us to identify every single object, every element that must be classified. So this is a schema of the process, create the models, export to IFC, an additional quality check in with the 3D models, and solve some incidents with the BCF format, but not modifying the design, only creating a report with all the incidents in order to be solved in the construction phase. And using the CDE with the lag that at the moment hasn't integrated with the GIS tool, and to create an web access to the GIS tool and this integration. So, I'm sorry. This is a picture of our some models integrated in the GIS tool, that in this case is the 3 tool. I'm not going to stop detailing the process to transfer IFC models into the database of the GIS tool. Oops. With this GIS tool, we have the chance to integrate some other extra information layers, and we can see some pictures with affected buildings, affected vegetation, land occupancy, and this is a picture of the CD that we are using and is prepared to use for the construction phase, of course, following the process according to 19650 and with a lag that is not connected to GIS. And we have the chance in this integration of the whole infrastructure to make more common analysis, specifically sustainability analysis about energetic efficiency, carbon footprint for the whole line, and establishing some variables related with those analyses in order to take decision during the construction phase, and some modifications that we know are going to be in this phase, but having more variables to do this decision taking. So I'm finishing in conclusions. All the information created in the detailed design phase transferred to a digital environment, homogenization and standardization for the entire infrastructure. We have to take into account that almost 20 different engineering and architecture companies were involved in this project, following the same rules but creating different documents. Easy to follow the construction, control the works, and create dashboard through business intelligence. An additional quality check of the detailed design project using OpenBIM as enabler, and with future connection with maintenance management system that is planned to develop a GIS inventory of the assets of the infrastructure, and some management system like structure or others that are going to be prepared. This is a pioneering project in Spain. It's the first time that 60 kilometers line it's digitalized completely. And nothing more. Thanks for your attention. And here you have my data if you have any questions.
Okay. Thank you, Jorge. Any question in the room? No? Maybe Mercedes, do you have one in the chat?
Yes, thank you very much, Jorge, for your presentation. I was looking at just at your last slide, well, not the conclusion, but the before, that you were talking about how you are actually thinking about having climate targets, like carbon targets. Do you already have the software to do this, or as Norcorsug was saying, that actually you are devising your own tools to do this?
We are, in my opinion, and as far as I know, currently the software is not sufficiently evolved or not at the level we need, and we are in the process of generating a specific tool using the database created and with a specific sets of parameters in order to measure carbon footprint and some other analysis. But unfortunately, we think that the software is not well prepared in this moment.
Okay, but yeah, basically I just hear for the two presentations that they are somehow making it also Boston a bit, so yeah, making their own tools, but you know, it is happening, so that's great. Good, so really, thank you very much for your presentation.
Okay, thank you. Bye.
Thank you very much, Jorge. Thank you very much, Mercedes. So we close this first session of railway and urban tram session. So the next one is within 30 minutes, I think. And Darmo, you will animate it. Okay, so thank you. Have a nice break and coffee break and visit to any companies which are in the exhibition center. Thank you. Bye.
Thank you very much.
Thank you, Mercedes.
Too many issues.
Yeah. Anyway, yeah, this computer is staying here. So I take all my stuff that I can give you. Don't worry.
Not yet.
You should start the presentation.
Yeah.
We should see it.
It would be better. We don't see you yet. Wait.
Okay.
The settings are very nice, Tarmo. Very nice red background there.
Yeah, this is very nice, amazing building.
I'm jealous of
Hi,
you.
Tarmo. Hi, Leon.
Hi, Claude. Three. Okay, she has. Do you have a presentation there?
Nope.
You should.
No,
I have it here.
no, we see nothing. We see nothing.
Yeah, it's here. It's already in the presentation mode here.
Ah, okay.
Okay, now we see your presentation.
Yes.
Great.
Great. Do you hear us?
Yes.
Okay.
Okay. And we are not in the picture now, I see. That was.
We see Tarmo.
We see Tarmo.
Yes.
And we see your presentation, the whole audience.
Okay. So we try to start in that way, huh, Claude?
Yes.
Okay. Tarmo, you have to click because you are running the presentation. If we say click, then please go into the next slide. So you can go to the next slide, please.
Can we also show Mark?
I will change. Okay.
Nice.
Second.
Okay. So, Marc.
Good afternoon.
Alors bonjour Lyon d'abord, hein, je vais commencer. Maintenant, Marc.
Unfortunately, we are not able to be with you this afternoon on site today. Claude is in Isaac, me in Zurich, and we hope that we can show you a good presentation from here. Next one. What we will talk about, we would like to give you a view into the innermost of a BIM model. At first, we will tell you who we are. We will start with a real-life example. Some provocations will follow in the presentation. A view behind the BIM scene is the main topic then in the next part, and impact on the application of the BIM methodology will at the end, and we have some giveaways for you in the next stage. Yes, my name is Mark Pingu. I'm a civil engineer, make my studies at the Technical University of Zurich. I'm working at Rosenthal & Partner, and I'm since 25 years in the railway business. My key experience are rail business requirements, system design, project planning, asset management, and since 2017, we support IFC Rail and SPP in establishing the BIM method in the industry. Thank you, Claude.
Yeah, my name is Claude Marchal. I'm also a civil engineer, studied in Strasbourg, and I studied IT in Amiens. I'm also an associate partner at Rosenthal & Partner. There I'm head of IT services, and I'm working for over 30 years in the linear infrastructures. My key expertise are process modeling, conceptual data modeling, IT project management, especially for linear assets. And I'm supporting SBB in the BIM program in the discipline Information and Data Management since 2017. I'm also a member of the technical service of IFC Rail. Yeah, just a short slide of RNP. What are our activities in the rail infrastructure business? We have three main fields of expertise which we combine in our mandate, which are process management, project management, and information management. Right. Next one.
Well, what we will start with a real life example. So the project was to design a BIM existing condition model. The specification said that the following object should be modeled: track and turnout panels, fundaments of catenary masts and cross beams, cable canals, and that in a level of information needed in a very small one, 200, just because this project, the existing rail and tracks, they will be removed and there will be a new one. So the target was not to have too many data, too many information which are just for rubbish. Next one. What we get then was a visualization model. When we have a look on that, you see that the track panels are technically correct, visualized with sleepers and rail. So that helps everyone to see, that's a railway track, a double track, maybe experts see already that's a standard gauge as well. That's fine. But there is every sleeper showed in the model and even individually selectable and assigned with an individual ID, properties, and a location. That was not ordered. So we have to be aware that this sleeper is really not real. It's a fake sleeper which suggests to the user information an accuracy that will only exist in the visualization model and nowhere else. It's a CAD sleeper generated by the design program. Next one. What we really wanted to see is a visualization model that is one-to-one to the data model. So in this solution, track and turnout panels are correctly modeled as ordered with track panel and turnout panel. It was illuminated here with colors that you see it a little bit better. A sleeper here is not an intelligent data object in the model, and it's not allowed to be selected individually. It's not needed. It was not ordered, and it's too detailed. If we need some important information of the sleeper in the panel, then it can be documented with properties of the panel. For example, the material, concrete or wood, or the profile, whatever. That's the goal, to have really the one-to-one approach from the model to the data model visualization. Yes, next one. We have some provocative statements from our daily business. You may smile a little bit. You can press the first one. Yeah, clicking by mouse on an object opens the view behind the scenes, right into the core database. The beauty of a BIM model is a business card for the designer, but not to meet the requirements of the customers that this testimonial. Too much. Too quick, yeah. The last one is people believe what they see, but they have to be always skeptical. What's the sense of that, what they see? So, while this is crucial, we will present you in the follow-up of our presentation. Now you can.
Yeah, thank you. Yeah, so Mark showed you this introduction, and now we will have a view behind the beam scenes. Just to remember that if we look at our infrastructure assets, and the cost methodology is to optimize with the data the operational phase. So we need a lot of data for that, and the data came from the projects. So we have to assure that the project information model can deliver at the end of the project all the information to the asset information model. Altogether, from our point of view, it's a conceptual view forming the common data environment. And let's see what is in a common data environment. Next slide. Yes. Basically, we talk about the same thing, namely our infrastructure assets. So it should be very simple for everybody on that. But depending on the role you have in the lifecycle process, the abstraction of the real world is slightly different. So we have the owner, which for him is important to have the requirement, to have the utilization of his infrastructure. We have the planner and contractor, which are mostly interested in delivering the project in cost and time, and so on. And we have on the other side, in the operation and the maintenance, the asset manager, which wants to have the best asset manager operate the asset management. But for that, if we see, we have these different views, and how can we bring these different views together? Well, we think we need a common terminology to define our asset system clearly, what we want, and then we need some model for the data, some data model. On the semantic level, we need a data catalog, and on the conceptual data model, we need some conceptual data models to be able to give the requirements to the common data environment where all things are put together. And of course, if we are looking at the exchange requirements we have during the processes, we need some standards. And here is clearly positioned the IFC standard. Okay, next one. So if we look a bit deeper into the CDE, what is the structure of such an object? Of course, we need the defined business objects, which are to be maintained in the beam. And for each object, we have three main parts which have to be defined. Firstly, we have to define object identification. It's a unique object identification which permits to manage and to retrieve the object over the life cycle. The second thing is also very important. It's the spatial reference of the object, which permits us to position it in the real world. And the third thing is the temporal aspect, so the historization and the prediction of the data and properties of the object to be able to follow all the life of the object in time. And Mark will present now some details on that.
Thank you, Gerald. You mentioned it, business view first. So we are working with business objects, with objects in the rail system, physical objects. Every one of you knows some of them. So at first there is a catalog with business objects to build and to prepare. They have process-related objects. Some objects are maybe needed only in one phase or of the lifetime, and this objects carrying the information about the specification and whatever. The objects has to be unique and with an international description. So that's the base that an exchange will work, especially that all these container can be exchanged between the systems and the errors. Some of the properties for identification to guarantee the uniqueness about an object. Then it's a set of properties for all the different processes which this object will be needed in. And as well standardized for a proper data exchange. So for example, IFC Rail as this data exchange format. From IFC Rail, you find this catalog of all the railway object type catalog with the models and the descriptions. They are available. So the first step is done to work with the business objects. Next one, Tarmo. The second one, what was Claude mentioned, is this unique object identification. You all have IDs and know some of this identification. I just want to say it's not only a local BIM model where, as we have seen in the beginning, turnout panel has an identification. No, this turnout panel is unique in the whole network. You can have it on the left side in an area, in a region of Zurich or in Switzerland, somewhere in the network. This panel must be unique. It must be has a unique identification, and at the bottom of the slide you see, and during the whole lifetime of the object, this identification must be stable. So from the start to the end. Yeah. That's already Claude's slide. Thank you.
Thank you, Mark. So we are switching to the localization and the positioning of the objects. Yeah. Oh, slide. A bit better with the slide. Yeah, thank you. Okay. Yeah, we well know for the positioning that we use currently geographical coordinates for positioning our buildings and so on. We have also the local positioning system inside the projects we use. But what is special for linear infrastructure is that we need something called a linear referencing system. A linear referencing system is something which helps us to position an object along a curve. And that is something we have. This is one special additional things in IFC 4.3, which was extensively tested also last year, and this will be a major extension of the IFC standard for that, which will help us in the infrastructure BIM to go forward very fast. Yeah, next slide, please. Here's just an example what is meant with a linear referencing system. We have our, for railway, we have our alignment with Kant, which is defined with three curves. We have a horizontal alignment, a vertical alignment, and a Kant alignment. And these three curves together are combined to give us the linear referencing system, on which we then can position the turnout panel. And this is the panel is positioned linearly on the alignment. That's one thing. And then the second thing is that we have some objects which are linearly positioned inside the panel, so that we need also a referencing system inside the turnout panel. That means that this example shows the requirement of nested linear referencing systems, which are currently available in IFC 4.3. Next one. Now the historization we talked about. Yeah. For that, we need as a requirement, we need to record every change happening on the turnout panel during his life cycle. So we have the first changes which are during the construction phase, from the planning to the commissioning, which are recorded the time aspects, and then we have during the operation phase all the activities like tamping, grinding blade, and replacing a frog, which either make a change in an attribute or also create a new object for that. And all these events have to be stored only with time attributes in the common data environment. Next one. Yeah. So now have a look in the visualization model Mark introduced at the beginning. If we set up these requirements for the location, the time, and the uniqueness, we should be able to generate the visualization model as a screenshot from outside the CDE using a filter. And the filter means that we can select the type of objects needed in a specific perimeter and for a point in time. And in combination with graphical parameters for visualization, we should then be able to generate a snapshot for different BIM models, like existing condition model or as-built model, and so on. So really, what is important is that we have all the data in the CDE for that, in the structure we mentioned before. Next one. What is the impact on the application of BIM methodology? What we want to do is we have to ensure sustainability in the future, right? So looking at the structure, we need this CDE with standardized structures, and the CDE will form the basis for the data exchange across all processes, and so we can avoid media breaks, right? What is also important is that we have in the structure we use for the data exchange, we use open and product independent interfaces for the data exchange based on IFC. Of course, for the identification of the objects, we have to ensure the uniqueness of the IDs, because we have in linear infrastructure, we have large infrastructure networks, right? And so for that we need to define some identification conventions. On the process side, we need to ensure the mastering of the IDs for the exchange between different systems, because we have a lot of spread data sets for that. The spatial reference, we need a distinct integration into global referencing systems. I heard in other sessions that GIS and BIM are very important, and that's exactly for that, that we need this integration with the spatial reference. And we have the standardized location of objects in the linear referencing systems, which are given now with the alignment concept, which was added in IFC. For the time reference, we need, of course, also to manage the updates of all the information over all the processes. For that, we need clearly defined roles and responsibilities for that. And on the structure side, we need this time reference mentioned before in the objects, which are used either as an information or also as a selection criteria or filter for the visualization. Yes, next one.
Thank
Mark?
you, Claude. You bring us already to the conclusions. Well, there are some really big challenges for the infrastructure company ahead. Today, we are in the middle of a change process. This way forward, it leads from small perimeters to large networks, from limited data sets to mass data, from a planar view to a linear approach, from high levels of details to simplified abstractions to avoid mass data, to make the performance, to keep the performance of the systems and so on, from project planning and construction to lifetime operation, from months to decades for continuously data management, and from graphical objects to intelligent, clever data objects. That's the challenge in the future. And the next slide gives us some, we would like to give you some giveaways. Please keep in mind, now the first row, keep in mind, a BIM model is not 3D, but it's much more boring. Next one. BIM project is only the birth phase. The long life follows afterwards. Next one. A standard now fits to everyone, but only due to it, everything fits together. Next one. BIM models are already out of date after they have been designed, unless they are systematically updated. And the last one. So, what is the digital twin now? It's the source. The source of all information is in the CDE. Next one. So, if we are able to model and describe this station entrance of the Zurich main station, then we really are on our goal. Many thanks for your attention. We will looking forward to see you then next time in Tampere again live, all together. Thank you. We are here now for question and answer.
Merci beaucoup. Merci.
Thank you, Mark. Thank you, Mark, and thank you, Claude. Now it's time for a few questions. Any questions from the audience? Karin, do you have any questions from chat?
Yes. The chat, no, there are no questions, but we do have some questions, Tarmo, that you very well prepared for us. So I'd just like to say thank you, Mark and Guy, for this presentation. It was very, very informative, and I'm glad to see that you are on the way to succeed in the big challenge of getting everyone on board with working with digital twins and BIM in infrastructure. I would just want to say to you, Mark, that 3D makes it not so boring, so we need to make cool 3D models to get all the project participants involved. Just one question that both Tarmo and I are very interested in is how do you have any tricks of getting busy project managers to see these data models as being just as important as the actual physical infrastructure when you're done? Do you have any thoughts on this?
Well, I think that one of the goals is that the people understand what is happening, what is behind, that it's not just the thing what they see, that there are logic things behind, that they have to start maybe early in the project phase with properties and with work. They not see the purpose for the moment, but they have to accept that with generating some information, the life start of an object. Claude?
Yeah, I think what is also important is to tell them that in the future, the contractors will not only want to get the system and the assets, but also the data. They are ordering also the data. It's a part. It will be a part. Structured data will be a part of the deliverables, a mandatory part of the deliverables. But this will take time. It's take time. You know, we are just also in Switzerland. We are just starting the process. Huh? We're just starting the process. I think in the Nordics you are far more forward than us. Maybe, I don't know. But it will take time, and we try also at SBB in the pilot projects and so on to make the importance of the data to show them that it's essential for the future. But it takes time. So we have no what do we say, magic answer on that.
Thank you.
Management.
And audience, any questions?
Are we finished? We have no more time, Tarmo?
Yeah, I think we say thank you for Mark and Claude. Thank you very much for your presentation.
Merci beaucoup. Thank you.
Merci.
Thank you. See you. Bye-bye.
Bye-bye.
Okay. Thank you. And the next presentation will be here in live. It's a development of an integrated OpenBIM IoT DL-based approach for the SHM of infrastructure, case of the Grand Paris Express Tunnel. Mr. Noor Eddin Al-El Haddadi, welcome.
Welcome.
Just a second, little technical break. Presentation is ready here. Okay, now you can start.
So we can start in French, no problem. Okay. Donc, bonjour à tous. Donc j'ai choisi de faire la présentation en français, mais vous pouvez me poser des questions effectivement comme vous voulez, en anglais ou voilà, en français. Donc les slides sont en anglais, donc vous pouvez suivre avec moi pour des gens qui nous suivent à distance. Donc voilà, donc ce que je vais vous présenter aujourd'hui, donc c'est un digital twin, c'est un cas de jumeau numérique qu'on a développé chez Secotech Monitoring pour l'activité d'auscultation. D'accord, donc c'est juste pour savoir que donc avant on était Semontis et à partir de 2022 donc on est devenu Secotech Monitoring, c'est juste pour voilà, pour information. Donc là, le jumeau numérique, donc on a intégré effectivement donc le BIM avec l'IoT appliqué à l'auscultation, donc tout le système d'auscultation basé capteur, voilà, avec bien sûr une composante de prédiction basée sur le deep learning, bien sûr afin de suivre voilà, les ouvrages d'une façon voilà, la plus efficiente et efficace possible pour nos clients. Donc, je vais essayer de vous présenter notre démarche dans ce cas de figure, sachant que on a déjà des projets donc, réels. Donc, on a appliqué ça sur le Grand Paris et après donc, sur la tour de Milange avec Hoffmann-Sémontrie. Donc, c'est deux cas de figure qui sont réels et on a vraiment senti donc, voilà, les fruits de cette démarche donc, de jumeau numérique. Donc, je pense que tout le monde maintenant il est convaincu voilà, de l'apport d'auscultation et de monitoring parce que voilà, donc, il y a des infrastructures et des ouvrages d'art qui vieillissent et parfois ils vieillissent mal, d'accord. Et les maîtres d'ouvrage aujourd'hui donc s'inquiètent pour effectivement donc prolonger la durée de vie voilà, de certaines infrastructures et ils recourent parfois effectivement à des systèmes d'auscultation et de monitoring automatique afin de voir effectivement donc les données derrière, comment ça évolue et suivre les différents paramètres. Donc ça c'est, donc je ne vais pas vous rappeler les drames qui ont eu lieu, donc ça peut arriver dans n'importe quel pays et pour n'importe quelle infrastructure. Donc c'est arrivé par exemple en Italie à 2 reprises pour les drames. Et voilà, donc c'était le cas aussi en France et ailleurs à travers le monde. Donc il y a toujours des cas pareils qui sont dus parfois donc, à un manque de suivi donc, de l'infrastructure comme il faut. Aussi, pour des projets en chantier, voilà, je cite le projet du siècle donc, de Grand Paris Express. Donc là où, effectivement, donc, le maître d'ouvrage a exigé donc, de suivre le projet en lui-même et ses avoisinants, donc du moment que ça présente effectivement donc, des exigences et des impacts qui sont énormes sur les infrastructures avoisinants. Donc aujourd'hui, donc ce Cotec Monitoring, donc il est sur 40%, voire plus, bien sûr, avec le nouveau marché donc de la 16.3. Donc on est sur la ligne 14, on est sur la ligne 15 sur 2 lots, on est sur la ligne 16 sur les 3 lots, etc. Donc, et on suit bien sûr prochainement donc les autres projets. Donc en fait, la particularité voilà, de ce genre de projets qui sont énormes d'envergure, c'est qu'on est face parfois donc, à plusieurs variables qu'il faut suivre et monitorer. On suit l'inclinaison, on suit le tassement, on suit la contrainte, la déformation dans des ouvrages souterrains, à la surface, etc. Donc beaucoup de paramètres qu'il faut suivre à la fois. Et on est sur des structures différentes, sur des parois moulées, on est sur des tunnels, voilà, donc de la convergence parfois. Et du coup, donc, les maîtres d'ouvrage demandent parfois donc, des niveaux de précision qui sont assez élevés et il faut bien sûr alerter lorsqu'il y a un problème. Donc tout cela voilà, nous pousse effectivement à choisir une démarche donc, de suivi, un système SHM donc, de monitoring qui est fiable, précis, voilà, et qui permet d'agir au bon moment et d'anticiper certains dégâts. Donc du coup, nous, ce qu'on a proposé sur la ligne 14, donc sur des sites pilotes avec Razelbeck, donc de développer sur des sites pilotes, effectivement, donc un système basé BIM, c'est un jumeau numérique, voilà, qui intègre à la fois donc des données d'auscultation avec des modèles BIM. Donc c'est du moment que en fait, les projets sont déjà en BIM et on a essayé bien sûr de les enrichir avec notre système sensoriel SHM. Donc, les objectifs spécifiques donc, derrière donc, cette approche, donc d'abord, donc, il faut qu'on mette en place une base de données structurée. Donc, de ces données, il ne faut pas voilà, faire envoyer dans tous les sens à gauche et à droite, mais plutôt, il faut que ce soit une base de données structurée qui va prendre en charge toute une quantité. Et c'est une problématique d'ingestion. Et voilà, vous l'aurez compris, que c'est une base de données qui est chronologique, dynamique et n'est pas statique. Deuxièmement, donc, sur la base de ces time series, donc on a fait face à des problématiques, c'est parfois les week-ends, donc c'est des systèmes qui fonctionnent en temps réel. Et du coup, on n'a pas voulu donc, multiplier les astreintes et on s'est dit, est-ce que c'est possible que ce système prédit effectivement donc, le samedi et le dimanche le comportement de ces ouvrages et parfois peut-être prévenir certains manques de données ou des trous, ce qu'on appelle les nonnes. Et du coup, là, on est arrivé effectivement donc, à répondre avec certains niveaux d'exigence donc, à cette question. Troisième partie, donc c'est effectivement, donc on ne va pas venir voilà, intégrer ces capteurs voilà, dans un modèle BIM qui est propre. Il faut que ça soit intégré voilà, dans une démarche Open BIM. Il faut que ça soit, voilà, il répond aux normes de l'EFC, etc. en question. Et du coup, donc, ça nous a demandé un peu plus de développement pour ce système, pour qu'il soit bien sûr conforme aux exigences en question. Et finalement, donc, lorsqu'on est arrivé donc, voilà, à avoir donc, ces trois piliers de la démarche, on a pensé à une intégration dans une plateforme collaborative où le client et le maître d'ouvrage pourraient bien sûr effectivement donc, faire les opérations et suivre leur projet comme il faut. Donc du coup, là, on a fait un appel à une notion, ce qu'on appelle le Monitoring Information Modeling. Donc c'est au lieu de, donc c'est du BIM, Building Information Modeling, mais puisque donc on l'a appliqué effectivement au monitoring. Donc ça, c'est un terme effectivement qui existe dans la littérature. Donc c'est le système SHM de monitoring. Voilà, qui est augmenté par voilà, le modèle BIM. Donc, c'est ce qu'on appelle le MIM, Monitoring Information Modeling. Donc, en quoi consiste effectivement donc, cette démarche? Donc, d'abord, on part d'un modèle voilà, BIM du projet, d'accord, qu'on peut développer chez nous ou bien donc, mis à disposition par notre client. Et après, effectivement, donc, on développe donc, le modèle BIM de notre système sensoriel. Les capteurs sont divers et variés et du coup, donc on essaye quand même de développer donc, cette stratégie pour ces derniers, bien sûr, en fonction de, voilà, des exigences en vigueur. Ça peut être de l'open BIM comme ça peut être de le close BIM. Et après, voilà, donc c'est la particularité de ces capteurs, c'est qu'ils sont dynamiques, ce n'est pas des objets statiques. Donc, du coup, il faut qu'on mette en place donc, une infrastructure de base, c'est une base de données qui va accueillir donc, ces données en question. Et au final, donc voilà, data visualisation et traitement. Donc, c'est-à-dire que dans un environnement BIM, où toutes les opérations de traitement vont se faire. Voilà. Donc, l'objectif du BIM, effectivement, à travers cela, c'est qu'il ne facilite, c'est-à-dire que s'il y a un problème au niveau d'une structure en question, on pourra facilement l'identifier et la repérer. Est-ce qu'il s'agit, par exemple, d'une corde de convergence à l'intérieur d'un tunnel? Est-ce qu'il s'agit, par exemple, je dirais n'importe quoi, donc une tête de paroi moulée qui s'incline ou qui se tasse, etc. Donc là, tous ces éléments-là, donc voilà, avec un modèle de jumeau numérique, on pourrait facilement le déceler. Et du coup, donc s'il y a une alerte en question, donc on pourra facilement la visualiser. S'il y a des interventions à faire, on ne va pas chercher dans les bases de données où vous imaginez bien sûr tout le listing et on pourrait bien sûr tomber sur la mauvaise information. Donc tous ces éléments-là, effectivement, justifient voilà, l'intégration voilà, du BIM dans notre système voilà, d'auscultation et de monitoring. Alors, donc, ce qu'on a remarqué lorsqu'on a commencé effectivement donc, ce travail, c'est que le standard IFC n'a pas intégré donc, ce genre de capteurs. Certes, donc, il a intégré des capteurs dans le bâtiment, genre un capteur de température, etc., mais des capteurs de monitoring, voilà, avec toute la liste exhaustive. Donc, on a trouvé que les énumérations sont très limitées. Donc, ils sont très limités et du coup, on a essayé quand même de se poser la question comment on pourra faire? Est-ce qu'on va documenter donc, le standard en question ou on va essayer de faire bien sûr des exports donc, de propriétés? Donc du coup, là, c'est une question ouverte qu'on pourra bien sûr discuter avec Building Smart International. Yeah. Yeah. So, donc les capteurs normalement, donc, comme j'ai dit, donc, on a préparé une base de données. We prepared the database. It's a chronological database that receives the time series from physical sensor, and then this database is connected to the BIM database. And we have a streaming in real time, and we can visualize and Sorry? Yeah, so you have connected the two databases, and then we have a streaming in real time. Yeah, and then we can configure the frequency depending on your need. Okay. So then, bon, je continue en français si vous permettez. Du coup, donc les énumérations, voilà ce qu'on a remarqué à ce niveau-là. Donc c'est qu'on a bien FC Sensor Type et FC Sensor, mais à ce niveau-là, les énumérations qui ont été définies. Donc du coup, on n'a pas les capteurs qu'on cherche, genre un inclinomètre, un extensomètre, un capteur de vibration, un sonomètre, je dirais, voilà. Et du coup, donc, ce qui nous a poussé un petit peu à réfléchir à des méthodes donc, d'export pour que notre capteur figure bien dans le modèle. Mais ce n'est pas juste quelque chose, voilà, sinon le maître d'ouvrage va nous dire que c'est un objet qu'on va nettoyer et c'est n'importe quoi. Voilà, donc la méthodologie, voilà pour répondre à votre question, donc elle est assise ainsi, mais bon, je ne vais pas effectivement entrer dans les détails, sinon ça va être un petit peu ennuyeux, mais conceptuellement, donc on a commencé par le BIM pour le projet en question, et le BIM du système sensoriel des capteurs, qu'on a essayé d'étendre, ce qu'on a fait la documentation juste de l'EFC. Et après, voilà, donc les capteurs aussi, donc ils ont une base de données. C'est à ce niveau-là où tous les traitements, où les données sont reçues, où les traitements sur les données brutes effectués. Et après, voilà, il y a une plateforme, effectivement, voilà, donc d'intégration, connexion base à base, qui permettent effectivement donc d'héberger toutes les données, les deux à la fois, et visualiser comme il faut, voilà, les deux systèmes. Voilà, donc du coup, ça c'est juste une information, donc ça c'est un petit morceau donc, de toute la base de données. Donc du coup, la question qui s'est posée, est-ce qu'on va opter pour le système SQL ou non SQL? D'accord, donc vous l'aurez compris, c'est que les deux, bien sûr, ils ont des divergences et des avantages et des inconvénients. Donc nous, d'ailleurs, on a publié un article dans ce sens parce qu'on a essayé donc de tirer profit, voilà, des deux approches. Donc c'est une base de données qu'on a développée, voilà, hybride, SQL à la fois et non SQL. D'accord, pour qu'on puisse effectivement donc garder le système tabulaire par table compréhensible et en même temps donc l'approche non SQL qui permet d'héberger les données de l'IoT du moment qu'elles sont massives. Voilà. Voilà. Après, voilà, donc j'avais parlé donc d'une composante donc de prédiction et de forecasting pour le week-end. Donc ça, c'est juste un exemple. Donc du coup, on a fait beaucoup de tests sur les données. Du moment que notre base de données il est assez riche, le projet on le suivait sur 4 ans, d'accord. Donc du coup, on a fait un historique de données, voilà, de 2 ans, qui nous a permis effectivement de prendre en considération les aléas, donc le week-end, plutôt l'effet de saison, l'effet de température, etc. Donc beaucoup de paramètres qui ont effectivement contribué à l'affinement, voilà, de modèles en question. Après, donc, il y a l'OpenBeam pour les capteurs. Donc, du coup, voilà, donc on a commencé, voilà, donc le projet, on avait déjà, c'est une Gérop d'ailleurs, donc qui nous a effectivement, donc c'est eux qui ont dicté, voilà, le système sensoriel à mettre en place. Donc on a respecté, etc. dans le cadre du marché. Et après, donc les capteurs, on a essayé donc de les positionner à leur endroit sur le modèle et on les a intégrés. Du moment que tout a été intégré, bien sûr sans perte de vue sur l'extension et la documentation qu'on a faite, sans que ce soit vraiment donc des énumérations définies, on a fait un export de paramètres de ces capteurs pour qu'ils soient bien sûr intégrés dans l'EFC en question. Et après, donc, lorsqu'on a défini l'infrastructure de base, on pourra passer à l'alimentation. Donc là, c'est juste un exemple. Donc c'est un site pilote de la ligne 14 du Grand Paris Express. Donc c'est la gare C3C. Donc, vous voyez que ce n'est pas un modèle 3D, mais plutôt un BIM. D'accord, on peut l'éclater. C'est un modèle intelligent. Chaque objet il est documenté effectivement. Et après, donc là, c'est 3 capteurs que je pourrais présenter. Par exemple, c'est un prisme, c'est un système topographique. Là, c'est un système de contraintes structurelles et l'autre, il est géotechnique. Par exemple, c'est un capteur inclinomètre. Donc, la liste n'est pas exhaustive. Donc, beaucoup de capteurs, beaucoup de développement qui a été fait. Et du coup, le capteur a été bien documenté selon les informations dont on aura besoin pour le requêter, l'interroger, etc. Voilà, et la liste, comme j'ai dit, n'est pas exhaustive, donc il y a beaucoup de capteurs dans ce sens. Et tous ces capteurs ont été effectivement pris en charge dans le standard et les exigences du projet. Voilà, donc on a fait des tests effectivement d'export pour voir effectivement est-ce que dans le modèle IFC on va retrouver les capteurs. Donc on a fait juste un export de paramètres, suite à quoi on s'est retrouvé effectivement avec des objets qui ont été bien définis dans notre modèle de sortie. Donc l'intégration au final, donc du coup comme j'ai dit, donc on a la base de données, voilà, du BIM. Après, on a l'hybrid database. Donc, pourquoi hybride? Parce qu'il y a à la fois le SQL et le non-SQL. Donc, c'est une base de données qui permet de gérer donc, le temps réel, le fait que la base de données elle est dynamique. Et après, donc voilà la plateforme d'intégration qui a été développée. Donc, il y a un front-end, un back-end et il y a un front-end. Et voilà, c'est au niveau de cette plateforme qu'on pourra effectuer les différentes opérations, la visualisation en temps réel, les graphes pour afficher les capteurs, l'intégration, la prédiction des données, la définition des seuils et l'interprétation, etc. Et on est en train d'interagir avec le modèle. Voilà. Et là, par exemple, c'est des illustrations. Ça, c'est juste des illustrations en phase chantier. C'est-à-dire que là, par exemple, c'est un projet en construction, c'est une boîte de gare, d'accord? Donc, c'est des panneaux de parois moulées où vous avez des capteurs, des chaînes qui sont définis, bien sûr, dans l'EFC et qu'on voit exporter ici. Voilà, c'est un modèle. On clique sur le capteur, on affiche bien sûr ces données et vous voyez qu'il y a toujours une composante en avance de prédiction qu'on a bien sûr validée avec plusieurs tests. D'accord? Donc on clique, s'il y a un dépassement de seuil, donc on a défini les seuils en question, s'il y a un dépassement de seuil, on serait bien alerté. Et ce qu'on a essayé de faire aussi, ce que vous voyez, c'est de la couleur. Donc l'effet de couleur n'est pas juste pour faire beau, mais plutôt ça reflète effectivement donc, la mise à jour d'un élément fini qu'on a récupéré et après ce qu'on a affiné avec les données du capteur. D'accord? Donc le capteur a contribué effectivement à voir, donc c'est un exemple de jumeau numérique. Là, c'est un exemple un peu, un peu loin, c'est-à-dire en phase exploitation. Donc la gare, elle est finie, etc. On a récupéré le modèle et on a gardé les capteurs, par exemple, des jauges de contraintes qui restent noyés dans le béton. Et du coup, on suit la déformation, etc. Vous voyez, donc on peut interagir avec le modèle, voir le capteur où il est, et le modèle est bien dimensionné. Voilà, donc du coup, les différentes phases qu'on pourrait avoir, les données elles sont affichées directement sur les capteurs. Donc, vous voyez des capteurs ici, donc les données sont affichées. Si c'est vert, c'est-à-dire qu'il n'y a pas de problème. Si c'est rouge, ça veut dire qu'on a dépassé l'alerte, etc. Et on peut toujours les désactiver, les réactiver. Et c'est des modèles définis dans le standard IFC. C'est-à-dire qu'on ne pourra pas dire que c'est juste nous sommes en train de faire de n'importe quoi sur le modèle. On peut les désactiver, les dissocier, ce sont des objets bien définis. Voilà, donc du coup, juste pour conclure et ne pas trop tarder, ce qu'on a mis en exergue à travers cette étude, c'est qu'on a développé donc, cette base de données hybride qui nous a permis effectivement d'intégrer les données des capteurs qui sont massives en temps réel. D'accord? Et comme je vous ai dit, on a publié un document là-dessus. 48 heures donc, de forecasting des données. Donc ça, c'est un modèle qu'on a affiné et qui est toujours, bien sûr, dans notre département de recherche qui est en train, bien sûr, d'être travaillé pour étendre cette durée. Et une intégration d'un système SHM dans un OpenBIM. Et là, c'est une discussion qu'on va ouvrir peut-être avec Building Smart pour voir effectivement si capteurs est-ce qu'ils ont été intégrés dans la version 4.3, etc. Et la plateforme qu'on a obtenue, c'est qu'il y a de la clarté, l'efficience et la rapidité de prise de décision parce qu'on voit effectivement le capteur où il est inséré sur le projet, qu'est-ce qui se passe sur ce capteur et est-ce que ça va ou ça ne va pas. Et du coup aussi, il y a l'interpolation qu'on a faite sur le modèle. Donc vous voyez l'effet de couleur. Donc là, c'est un modèle complexe qu'on a essayé d'intégrer et que nous sommes toujours en train d'affiner. Voilà, donc du coup c'est ça. Après, les perspectives et les limites, c'est le sujet qu'on vient d'évoquer, l'FC tunnel, FC sensor, est-ce que c'est quelque chose qui est limité ou on pourra bien sûr développer davantage les énumérations. Et cette application, donc voilà, nous sommes en train de voir aussi le fait d'intégrer le SIG 3D pour insérer le projet dans son environnement et faire bien sûr de l'analyse spatiale à côté. Et les éléments finis aussi, pour avoir un modèle dans ce sens afin d'enrichir davantage les applications. Et ce qui reste qui est en frein ce genre d'application, c'est que les maîtres d'ouvrage, ils trouvent ça du luxe. Il faut développer davantage ceci et démocratiser ce genre de projet pour qu'on puisse aller plus loin. Et je vous remercie pour votre attention.
Merci Noureddine. Tarmo, can you hear me?
Yes, hello?
Yes, hello, Tarmo.
Okay, thank you very much for a great presentation. Does anyone in the audience have questions now? There is one question. I will give it the mic. Wait.
I think it was the slide 12. If you come back to the slide 12, number 12. I know. Yeah, here. What do you mean by no support for SHM sensors in civil engineering?
So I mean that here in FC sensor type enumeration, we have not an exhaustive list of sensors that we have in our system. We have like a sensor of temperature, a sensor in building, something in building, but in our case of our structure, we have a lot of sensors that not figure here. So their propriety, we can't export them in our model. So that is why we put this remark, and it is an open discussion that can we have with Building Smart International to see if in their last version it is integrated or not.
I think, Timo?
Yeah. You were talking French, even you speak very good English.
Timo, can I comment on the question regarding
yes?
IFC 4.3? You cannot
yes,
hear
Karin.
me. Yes, okay, thank you, Timo, yes. No, I'm really interested in all of these issues regarding the sensors and the lack of some of these concepts in the IFC 4.3. I think the infra room would be really interested in looking at, perhaps together with you, and also the ongoing European CEDAR initiative that both Timo and I are involved in. I think this would be really interesting. So Timo, if you can collect the contact details, maybe we can discuss this further.
Okay.
Yeah, I will take your contact details. Any other questions?
The IFC health monitoring project in the infra room, okay?
Yes, I think IFC health monitoring process would be very interesting, especially in COVID times.
Yes.
Okay, thank you very much for your great presentations. Yeah. Okay, our next presentation is BIM in new main lines in Sweden, case the East Link project by Jitka Hototskova from the Trafikverket, the Swedish Transport Administration. And this presentation is video presentation. So I put it here or you put it?
Hello, I'm going to be presenting for you today BIM in new main lines in Sweden. Hello, I'm going to be presenting for you today BIM in new main lines in Sweden. Ralte, who was part of the huge BIM effort, received my PhD title. And the last 10 years I've been working with the East Links project. Before I came to Sweden, I have received my PhD title. And the last 10 years I've been working within railway. I have been In the picture, these fields are mandatory and this last field is optional. The first two characters, which you see right here, describe the responsible designer, in this case E2, and this is in the SB11 language, overhead line designer. The following 6 characters right here, they describe element. Element is indicating the functional part and construction work or structure. The next 2 characters, they are presentation, and presentation can be, for example, 3D, 2D, centerline, or text. And the very last character describes status, and it defines if object is new, existing, temporary, or for demolition. Since there was no established working with models, we needed to establish even this project. Models delivers from designer to the project client. Designer presents the whole data delivery in some kind of meeting. Simple presentation of coordination model holds. Presentation of views and model products are presented. And finally, the review of the model per technical field is presented as well. I'm going to be talking about the cooperation within the new mainlines. The background to this works is that the existing requirements was very poor and inexplicit. This was of course opening for different interpretations and frustration at both sides, both at contractors and at consultants. So our goals with the BIM requirements for the Eastlink and the new mainlines was to make a complete set of BIM requirements which are easy to understand. It was also very important that the requirements are clear and that there is only one way to interpret them. All the requirements are gathered in one database. This leads to consistent BIM products deliveries, and this way the BIM designer can also give more support to the project's leaders. In this picture you see the common requirement BIM database in the new mainlines projects. When the requirement database is used within the whole new mainlines projects, possibilities to implementations just expand. You have updated requirements which are implicit. We could connect other content to the requirements in the database, such as support text, checklist. There's a possibility to connect with the object library, and of course automated procurement. And we have also created requirement working process. And in this animation we show implementation of the requirement, but just from different point of view. This time we show that if you use the same requirement database, it is possible to use it, for example, for the whole Swedish Transport Administration with just a small adjustments for the projects who need it. The database also helps the different projects that use it to have control over requirements changes both within the projects but also compare to main database. And you can also have project specific procurement depending on the contract. This also means that in the delivery stage, every project has a full control over implied BIM requirements, even if they have changed throughout the project's life cycle. My colleague Janne Perret was a project leader for the requirement database. And finally, in this last picture, I would like to show you why we did all this work with BIM and digitalization both in the Eastlink and the new main lines, and what is the main and ultimate goal. It is of course the challenge between delivery of the data from production to the different maintenance system. And I think that this is not only specific for the Swedish Transport Administration. I think a lot of other countries knows this problem. It is very important to work with coordinated information structure, as we already do now in the Eastlink project. But we are not, of course, done. It is even more important to continue working through the whole information life cycle and all the way to the different maintenance systems. Because when you have the coordinated structure, when you use the coding systems, then it's much more easier to deliver from this uniform surface for local projects where you have documentation, properties, graphics, and metadata to all these different systems and functions which you have at this other end where the maintenance operation system is.
Okay. Thank you, Jitka. And now I think Karin and Jitka should be there in the virtually. Can you hear me? Karin and Jitka?
Yes, yes, we can hear you.
And Jitka is here, yes.
Okay, that's great. Thank you for the presentation. It was very interesting. Now, do we have any questions from the public on site?
No.
No?
Rella is not delivering any questions today. But we do have a question some prepared. Do you have anything in the room, Tarmo?
No, any questions in the room? Please go ahead, Karin.
Okay, Jitka, how has the industry taken the usage of BIM in the Eastlink? What have been your biggest concerns and burdens?
Well, as I said in the presentation, the biggest concerns were that the industry pretended that they are much further than they really are. The problem is if they can work on their own and if they can work after their own requirements, then it's quite easy and they have no problems. But once we set requirements from the Swedish administration in order to be able to use the data and deliver them to the maintenance or use them for the building, then we see directly problems because they're not used to working like this.
Yeah, of course, we both worked in the Swedish Transport Administration, so this is really some questions asking to myself, but one of the questions that is of great interest, I think, to more people is the possible handover of this information to asset management. You mentioned it briefly. Do you want to say anything about the development forward?
Well, that's once again, as we mentioned, or I mentioned in the presentation, you have to ground it on the requirements. So all the deliveries look alike. We have the same structure of the data, and then we can start to work on the maintenance side with it. How does the data deliveries look like? Do we need to do some adjustments to our systems? And how are we supposed to adjust our systems? It is very hard for maintenance to start to prepare for those deliveries if the deliveries are if they look differently every time somebody else delivers. So it's hard. It's really hard for maintenance to adjust to these changes if we don't have requirements which make the deliveries look alike.
Yeah, I think what I was after was what Anna Neidenström will present a little bit more tomorrow, the way that the maintenance department now in Swedish Transport Administration, they have started to look at our deliveries and what it means to them and how they can make their own processes more efficient with working in the same way as we are in the construction phase. But this is all for the future. It's only just started.
Yeah.
Tarmo, do you have any?
Is anybody has question? Here is one question in the public. Just a minute, I will get the mic for Roland.
Hello, it's Ronald speaking. I was curious about the data transfer between the project database and the maintenance systems. If you have already some solutions in mind or are using them, are you using, for instance, APIs, web services to transfer the data, or what are you using for that? And how are you validating the data which is required for the different systems based from the project data model and system?
Do you want to say something, Jitka, or should I?
I can say that for our part, we are too early in to be validating data for the maintenance. As I said, we are in the planning phase, and now we are starting to plan for the building phase. But you can, Karin, definitely fill in as you are working on projects which are much closer to the deliveries.
Yeah. Yeah, we do have a few development projects together with the maintenance department that will be presented tomorrow in the S14 stream, starting at 11:30 tomorrow. It's the third presentation that will be held by Anna Neidenström. She will present the development that is ongoing, Ronald, and we are looking at linked data and that type of technology. We're testing it right now to hand over some bridges and some lighting systems in a road project. So we do have quite clear views on it, but of course it's all in the starting blocks at the moment.
And then we can also add, I don't know if it's specific for the Swedish Transport Administration, but we have come further with the road projects than with the railway projects, especially when thinking of deliveries.
Yeah, we do have a project that is delivered at the moment, but we have a very good dialogue now with between the different parts of Trafikverket, building, maintaining, and also managing the traffic, of course. So there is a lot of good dialogue going on already.
Yeah, that's a very positive development.
Yeah.
Okay, thank you very much, Karin and Jitka. Tack så mycket, Karin och Jitka.
Tack så mycket. Tack så mycket. Thank you very much.
Thank you. And then we go to the last presentation, which will be here. Yeah. The name is Full BIM Design of the new M3 Toulouse Metro Line, Focus on South Aerial Sector, and Mr. Christophe Fanovong. Yeah. Sorry, my pronunciation.
Thank you for being here. Thank you for being here for the last session, just a few minutes before a glass of wine. I'm Christophe Nouvong. I'm working for Arcadis, and I will present you today the new project of Toulouse Metro line, the third line, and we'll focus especially on the southeast sector, which I am the BIM manager. We'll begin with the general presentation of the project, and we will try to explain to you on which consists the project. And just after that, we'll present the different process that the different BIM process that we used in the process. And the first design phase, the first design development phase, the phase 1 and 2. We will talk about the last phase of about the construction document phase, where I couldn't show you a lot of images, but a lot of pictures, but I will try to explain to you what we done with it. The city of Toulouse, for the people who don't know what it is, which city it is, it's capital, European capital of aeronautic and special industry. It's the fourth in France in terms of ranking of population. And a city that known a lot of attractivity, so a lot of people come to that city for now. And it has already a good transportation network. A good transportation network with 2 metro lines, with 2 tram lines, and an important bus network. But it had reached the limit with a lot of people who come in the city for now, and so it began to be essential to link the northwest part of the city and the southeast part of the city, northwest part of the city, where is the Airbus company work. So this is why is born the. This is from this necessity of having this necessity that has born the third line of third line of metro of Toulouse, which we could also call it M3 or TE. For Toulouse Aerospace Express. It's a 27 kilometers project long. It's composed of 21 stations and principally underground, and with 5 kilometers of bridges, especially in the southeast part, in which we will focus on, and also a little part on the northwest sector. Since April 2019, we work in different joint ventures, in different design team on the project. I will just see someone. On the northwest part, there is Artelia and BG for this part. On the center part, we worked with Sistra. Sistra is the main contractor for the center part, and we work also with 3 other architecture firms. We work on the southeast part, where Arcadis is the main contractor, with another company firm called Séquence, and another engineering firm called OTIS. And we work on a Connex project. CLB is a connection line B. We are the main contractor also on this part, and we worked with Sistra and also Sequence. We can. There is also another project we call LAE for Line Aéroport Express, which Ingeropt is the main contractor for that part, and it worked with Conseil d'Ingénierie, Gauthier Conquet Associés, and more other engineering company. For the southeast part, so our client is TCO, and as I said before, you could see that there are a lot of actors on this project. So on this part where we will focus and where Arcadis is the main contractor, it's a part that it's a sector that is 5.1 kilometers long, completely aerial, with 4 aerial stations and with one shared station with the Line B connection. The Line B connection is the project that is the project that connects the line B to the new metro station. As many projects, this project has known a lot of different phases. Since June 2019, we began the first design development phase, and we worked on the second design development phase from June 2020 to March 21, and especially on this phase, I will focus the presentation later. Since 2020, the rail system designer has been nominated, is Alstom, and it worked with us. They work with us on the last phase, on the last document construction phase. And the construction phase will normally begin at the end of 2022 to finish for the civil part in 2026 normally, and normally the service launching will be made in 2028. With a lot of different actors on the project, and with open bin norms that just began in the infrastructure, it was very important to make BIM collaboration at level 2, and it has to be well thinked since the beginning for not having problem later. So we have three main principles on the project: the organization, the communication, and interoperability. Concerning organization, with the new project in the digital transformation era, we need to have a new objective, and this is why we need to have some innovative processes. And the TCO collectivity and TCO engineering, our client, has made the implementation of BIM one of this priority on the project. And this is why they worked with, they are assist with a BIM supervisor since the beginning of the project. Since the tender phase, they made the book BIM specification that ask all the participants of the project to respect open BIM norms and IFC format for all the exchanges and for all the deliveries. And for having maintenance later on the project, and for the city to maintain the entirely network in the city, and to maintain the city with the IFC, it was very important to be surrounded by this BIM supervision unit which have some missions to have the coordination, the beam coordination. They lead the general beam coordination and to uniformizing the different level of details and beam deliveries between all the different actors, and to create the general beam models, breakdown structures, authoring different updated beam details on the specification book, and verifying the conformity to the beam client specifications from all the deliveries. In our different sectors, we have also different missions, and we have also the different missions as Arcadis. Since we are beam manager on the project, we have to uniformize the different beam deliveries into the groupment. We write we author the beam execution plane. We have to identify the different contributors beam, etc. And we have to organize the different beam reviews that we have on the project, and to verify also all the different advancement on the project, and to verify the global coherence between all the different deliveries that we have. I think you are all okay with me to say that a beam collaboration project like this, we need to have a good common data environment interface, and we can't do without it. So to have a permanent control of the different exchange from our side, from our design team, and from the client part, we use different common data environment. We use, for example, Prozis Mezzo team. We use also Autodesk BIM 360, and we also use Bentley ProjectWise on the project, on the center part of the project. Concerning the CD that worked on the southeast section, Arcadis has decided to organize all his production to different all his production to Autodesk BIM 360 platform. About this exchange of to manage all the different exchange between the models, between IFC models and Revit models, with the architecture firm Sequence, and with the other engineering firm OTIS. The coordination work and the different compilation that we have on the model has completely realized in the cloud, without never on our private server, and that was very useful during the lockdown and during the different smart working session that we had the last times. So we had a better workflow, and we have a better validation processes on the different level. The interoperability that given by the IFC format has helped us to face many challenges that we had to uniformize and to coordinate the production within different teams. Three on the project scale. Three or four different architecture firms, 5 engineering firms, and we have less in our field, in our section, and we work on with very mixed environment in BIM, because different software has been used during the project, and with all the different actors. Depending of the different type of asset that we have to model. We use Autodesk Revit, Sophistic Bridge Modeler, and we also use ArchiCAD, Civil 3D, and GeoMedia Covadis. This is not on the schematic view, but we also use Bentley OpenRail for the more recent phase. And everything, all the different software that we use, it was very important to respect all the client demands on the project, especially on OpenBeam. So especially on OpenBeam and on the different structuration of the project, because the project is cut in different asset, sector, and different disciplines that we have on the project. Also, we have a lot of different attributes and different parameters that the client asks us to put on every element of every model that we have. We talk about more like 20 parameters that we have to put on the project. We use the software, the Sophistic Bridge Modeler software, which is a plugin on Revit to model the different bridges that we have on the project. We have already made a lot of BIM project with bridges before in Arcadis, but it takes a lot of time before using this software. So we have to find something more dynamic on a project, and this is why we found Sophistic Bridge Modeler, because we already use Revit as a software for modeling all the different projects that we already have, and Sophistic Bridge Modeler as a plugin use Revit, use all the main components of Revit for 2D plans, for example, or also for the database management. So this is why we have succeeded to implement all the different information that we want on the project. And this has permitted us to have something more dynamic. We could have an alignment on the project. This is not a fixed geometry. So with the alignment, we can have different elements attached to this alignment, and so this alignment could be updated, and all the different elements could be updated with the alignment. So we created a lot of different parametric families before, and it takes just a little time before beginning the project, but after that it gives us we won a lot of time with that software. Also, we have very precise implementation of the different piles and different pile station, and we could make some bridges with double curbs, which is very difficult to model without a special software like that. And we could also generate real longitudinal section, which is quite impossible in Revit without it. But it's not something magical. The bridge modeler will not model everything for us. We need some experience. We need to know the state of art on how to make bridges before using the software, and we have to set up every element to have something usable and something quickly updated, that we could update it very, very quickly. If we talk about updating, it could take up to 1 hour to update just one model if you update something in the alignment, for example. So we have to manage everything before to have something very efficient before that. So the challenge for the next phase, for the actual phase, for now, for the document construction phase, is to raise the level of detail and to output with the precisions the different material distribution on some particular bridge on the project. We also have more 2D plans that come from directly come from the models, because for now, for all the detailed element that we have on the model, we have to use traditional CAD software to put more details on some plans. And also we want to make, and we have made some pre-stress simulations on the project. Another challenge is to model all the environment for the bridges, all the environment, because all the projects is aerial, which is very difficult to make it manually, because we have the chance to have a lot of quantity of data before the project, and this data was mainly in GIS. We have different type of GIS data. We have point cloud. We have ASCII data. We have orthophoto in ECW. We have different building. We have different building in geodatabase. We have also all the water zone and all the different existing network on the project. So after different experimentation, we have found just a workflow, and we use InfraWorks to compile the different elements of topography, orthophoto, different buildings, all the different water zone and vegetation, and all the environment in our production software in Revit, so we could have all this by InfraWorks. For the environment in IFC format, they are generated by the topography and the orthophoto that we put in Civil 3D there, and export that to IFC, and so to export that to the client delivery. And everything with all the different attributes that we have on the project. As I said at the beginning of the presentation, we are now in the construction document phase. I can't show you a lot of different picture of that, but we have a lot of different feedbacks from the precedent phases. We have increased the level of details. We have reinforced all the different technical coordination, and we found a better way to have collaboration. Concerning the level of details, we not only increase the graphical detail, but we also increase the information that we put in the model, which is, I think, one of the most important things that we have done. We use unit class 2, and we use a work in progress unit class for bridges to implement all that in the project. For the BIM and GIS interaction, for that phase, we didn't increase a lot of the process, but we would like to have more thing on it. So with the different phases and with the different feedbacks that we have from the precedent phase, we have a sort of wish list for IFC, where the IFC could bring us further in the projects. We had the chance, as I said before, to have a platform with a lot of GIS data on it, which is called the maquette de l'état existant du territoire, which that we would use directly and automatically the data from this platform to our production software, and vice versa. We want to invert the different things. For example, all the different IFC models that we have, we want to put directly in the GIS platform, which is based on ArcGIS Online, but it was not possible at this moment. For all, for example, to validate all the different deliveries that we have on the project. So we could still see some incompatibilities between IFC and GIS, but we know that a lot of different actors worked on it. And I think it could bring the project in a further place. Concerning the IFC format itself, we have used the version 2x3. Why 2x3? It's an old version because of the compatibility between the different software. We wanted to use the IFC 4.0 at the minimum, as asked at the beginning of the project, but we noticed that some software like ArchiCAD or Civil 3D, the import-export engine, that IFC engine inside this software, are not very satisfying for all the different exchanges that we have. We wanted to have better geometries on it, and I want to avoid some triangulations on the different elements of the projects. Also, I think for everybody, we want to have some real IFC class for infrastructure elements like bridges, geotechnics, alignment, rail, etc. But it is not possible again unless with the 2x3 format. So we wait for 4.3. We want to have it soon as possible. We also see some classifications problems with the uniclass for bridges, for example, because the client wants us to structure everything in the model with uniclass, and for using it for the maintenance phase and for maybe his future digital twin. But for now, it's still difficult because everything is in working in progress. And for example, we found we can't match the different IFC class with any format, and to have so we have made some compromise on the project. We noticed also that Uniclass 2 and Uniclass 4 bridges share the same codes on the project. So, for example, an element in the building have the same code in the bridges, which can make some difficulties to have a good structuration of the project, because we have also some buildings like station, like upper ground station, and so they share the same classification. So it's still difficult. use it. Thank you for following this presentation, and don't hesitate to ask me more questions. I will be today and tomorrow here.
Okay, thank you very much.
Thank you.
We have time for one question. Is there any questions from the audience here? If not, Karin, can you help us?
Yes, I was wondering a little bit regarding the next phase. So for handover, you mentioned that you have requirements for handing over IFC. You say the client had a wish to work with BIM models, although I hear a lot of drawing production not being made from models, which is, of course, sad. But what does the next phase look like? Is it
on the models?
Is it going to be yes, for handing over?
The importation on some productions software is not possible with the IFC 4.0, for example. We don't see the geometries, so it's quite difficult to have some special coordination on the project with missing elements. So we noticed yes, some problem with the geometry principally. Even if the software is certified by Building Spark, but so we notice some problem with some IFC engines. Yeah. For example, in our KiCad or Revit, we have some problem with that.
Yeah, I think we are all longing for IFC 4.3 to come out into the market, and I hope the software vendors are listening to this and implementing as quickly as they possibly can. But what's the client's view on using models actively in the maintenance phase? I think that was my main question.
Okay. He have a different detail. He want to use the different software you want to use the Uniclass format principally. It's in work in progress for the client. So the client asks us to do something, but he think about what he will do with all the information that we have. So it's some work in progress in the two in both sides. So
Okay.
we don't know exactly what the client wants with all the informations, but he will not have informations with on the models.
Well, thank you.
Welcome.
Thank you very much for presentation. Let's give a big hand for all the presentations this afternoon. Thank you.
Yes.
And thank you, Karin, for co-chairing me.
Tarmo, I miss you.
I miss you too. Okay, thank you everybody. Now it's time to have a glass of wine downstairs there. So thank you very much, and let's continue tomorrow. Bye-bye.
Bye-bye.
Bye-bye, Karin.